A certain quantity of gas having a volume of 5 meter cube at 1 bar and 27 degrees centigrade is heated at a constant pressure to 55 degrees centigrade. Find out the heat transfer during the process. Take Cp is equal to 0.946 plus 0.184 into 10 power minus 3t and Cv is equal to 0.653 plus 0.184 into 10 power minus 3t. So here in a constant pressure process, the heat transfer is given by mCp delta T. Here take Cp is the mean value of the take Cp sorry here given that Cp is a function of temperature and take the mean value of Cp here, that is Cp is equal to 0.946 plus 0.184 into 10 power minus 3 into 300 plus 328 by 2. So which gives a value of 1 kilojoule per kg Kelvin. So now here delta T is a known value, that is 50 minus 27, and we'll have to find out the mass flow rate. Here from the perfect gas law equation PV is equal to MRT, we can find out the mass flow rate. Here initial value of P is 1 bar and V is 5 meter cube and T is 27 degrees centigrade and R is equal Cp minus Cv. Here Cp minus Cv is 0.946 minus 0.653. So from these values we can find out the mass flow rate, which is equal to 5.69 kg. Now the heat transfer is equal 5.69 into 328 minus 300, which is equal to 159.32 kilojoules. So for a lubrication system to cool 1000 kg per hour of oil of Cp is equal to 2.09 kilojoule per kg Kelvin from 80 degrees centigrade to 40 degrees centigrade by using a cooling water flow of 1000 kg per hour available at 30 degrees centigrade. Find which type of flow the heat exchanger system it is. So here heat rejected by the oil is taken by the water, so that the heat rejected by the oil is equal to mCp delta T of oil is equal to heat gained by the water. So here both mass flow rates of both oil and water are equal, but here Cp of oil is given by 2.09 kilojoule per kg Kelvin and change in temperature is 80 minus 40, and here Cp of oil is water is 4.187, and here the inlet temperature of water is 30, so that the final temperature of water, let us say T2, so that from this equation we can find out T2, that is equal to nearly 50 degrees centigrade. So that is, suppose if you consider a parallel flow heat exchanger, that is here the oil enters at 80 degrees centigrade and leaves at 40 degrees centigrade, and here cooling water enters at 30 degrees centigrade and leaves at 50 degrees centigrade. But here it is not possible, because the temperature of the exit of the oil is less than the exit temperature of the water. So that if you consider counterflow heat exchanger, in this case it enters at 80 degrees centigrade and it enters at leaves at 40 degrees centigrade oil, and here water enters at 30 degrees centigrade and leaves at 50 degrees centigrade. So that the only possible way is counterflow heat exchanger can be used. So that the type of heat exchanger is counterflow heat exchanger. Typical method of casting is used to. Here the right answer is obtain high density and pure castings. Monumental is an alloy of here monumental is an alloy of copper and zinc. List 1 with list 2. Here the list 1 consists some control process, that is incoming material control, statical quality control, process control, product control. Here list 2 consists their functions: quality of the outgoing product, right quality of raw material, evaluation of the capability of process, basis for determining the behavior of a process. Here incoming material control, the function of this control is right quality of raw material, so that one message B. And here statistical quality control is take care of basis for determining the behavior of a process, so that it matches with D. And here process control The functional process control is evaluation of the capability of process, so that 3 matches with C. And here product control takes care of quality of the outgoing product, so that 4A. Following statements is used for cutter size definition. Here the right answer is auxiliary statements. The maximum thickness for arc external cylindrical finishing grinding operation. If work diameter is 40 mm, wheel diameter 30 cm, wheel velocity 26 meter per second, work velocity 1 meter per second, the infeed 0.14 mm, and its abrasive grinds are 0.8 mm apart. Here the maximum chip thickness is given by 2 into small v nv is equal into root of d plus d by dd into f, where small v is the velocity of the work and capital V is the velocity of the grind wheel, and here n is equal 1 by 0.8, that is the abrasive grinds distance. So here capital D is the diameter of the wheel and small d is the diameter of the work and f is the feed. Now substitute all the values here and we can get here 0.00386 mm. In an inventory control theory, the economic order quantity is, it is a optimum lot size. With list 2, here list 1 consists some types of materials, that is the nature of the material: abrasive, cementing materials, minerals, refractories. And here list 2 consists different types of materials: quartz, calcite, alumina, carborundum, Portland cement, lime, etc., bricks, tiles procline, and silica bricks, and magnetite. So here abrasive materials are alumina and carborundum, so that here one matches B, and cemented materials are Portland cement, lime, etc., so that 2C. And here minerals are quartz and calcite, so 3A. And here refractories are silica bricks, magnetite, so 4E.